any transmission and any communication system always have to stick to very strict rules to make it compatible and to have the receivers ready and operating any place and in any conditions. So let's talk briefly about regulations. And the standards are the set of rules that define how the system should operate. In this particular case, for satellite broadcasting, then we really have a standard. The name of the standard is the Digital Video Broadcasting, DVB, and now we are on the second generation of this standard. It's a standard that was developed by the European Telecom Standard Institute, ETSI, and really was done with the participation of a large consortium of industrial bodies. You can go to this website and get all the data on the standard and see how the standard is being developed and new features are being implemented in the standard. But just to make things simpler, here follows a very simple description of the most important features of the standard. The first one is that it could deal with very different inputs. It could be video, MPEG, or some other formats, or it could be just a data stream where you just keep sending data for other purposes and they are not, let's say, directly related to an image and a compression format. Second is that the receivers are using very powerful forward error correction combinations of different codes. And that's because they intend to have the transmission that should almost have no errors. And they define in the standard that situation of having almost no errors as having, look at the number, less than one uncorrected error event per transmission hour. That's just one error per event per hour. For a TV signal, a typical TV signal of 5 megabits per second. That's the standard and it's a good signal. And this is equivalent to having a packet error rate of about 10 to the minus 7. With those codes, they could really operate at, let's say, from 0.7, around 1 dB from the Shannon limit. So that means that those codes really correct and detect error so well that you are almost at the limit of the best thing you can do in this process. And in this standard, they use a VCH and LTPC. That means the Bose, Chowdhury, and Hockenheim code, and with this is a cyclic code and a low-density parity check as an inner code. They combine two codes, and depending on the quality of the bits, they could also use different frame lengths. But that's the basic. But this is just the concatenated system of codes. And those code rates are, some of them are really 1 to 4. That means that for every single information bit, you add 3 more check bits. So look at, you are just sending much more checks than information bits, up to 9, 10, and in this case, you only add 1 bit to every 9 information bits. So depending on those bit rates, then the signal-to-noise ratio is going to be quite different. And also they could accommodate different modulation schemes from the basic QPSK to 8 PSK. So this is just for broadcasting, just to receive the TV signal on the ground. But for more professional, more demanding applications, they could go to 16 and 32 amplitude and phase shift key. So depending on the service, really they could have very different modulation schemes. From this basic, they start more or less at the spectral efficiency of half a bit per symbol and goes up to 4.5 for those other cases. And they can operate with very low noise signal-to-noise ratio, down to -2 dBs for the basic one, with a lot of, certainly, of redundancy. or up to requiring 16 dBs of signal to noise ratio for the more complex schemes, and let's say for this kind of code rates. And also they could shape the pulses with different, let's say, filter roll-off. That's the way the filter falls, and those numbers could be from 0.2 to up to 0.3, depending on the system in use. So it's a broad spectrum. You could accommodate many different situations, and just to give you a short set of numbers, you can have a more detailed information in this paper. And here on this line, on this column, you have the 4 modulation schemes we talked about, and here you have some of the code rates: 1/2, 2/3, 3/4, 9/10. And this is just the signal to minimum signal to noise ratio required to work properly. For this combination of QPSK and 1/2 code rate, 1 dB should be enough. If you move to 8 PSK and 2/3, you need 6.6 dBs minimum. That's the number we're going to use in the following study. And you see that if you keep increasing the complexity of the modulation and the code rate, then you may require up to 16 dBs of signal to noise ratio. So depending on the scheme of modulation you select and the code processing, then the signal to noise ratio could be quite different.